Today we will take a look at RGB LED. I will show you what is inside them and how the colors are created. And we will replace our basic LED with RGB LED. This is a standard RGB LED. It looks just like a normal LED, but inside it contains three separate light sources. RGB LED came in two common housing types. A transparent case, where you can often see the internal structures, like this one, and diffuse milky case, which blends the colors more evenly. Now I connected the RGB LED to a very simple test circuit. Each color channel has its own potentiometer, so I can control red, green and blue independently. This setup allows me to manually change the brightness of each internal diode in real time. Now if we look very closely at the LED, you can clearly see that this is not a single light source. Inside there are three separate diodes, placed next to each other. Now I can control blue color. This one controls green color. And this one controls red color. At this point, you may ask a very logical question. If there are three separate LEDs inside, then why does an RGB LED usually have only 4 pins and not 6? The answer is simple. Inside the RGB LED, one pin is shared between all three diodes. And this brings us to the two main types of RGB LEDs, common cathode and common anode. First, one very important note. All LEDs in both of these test circuits are connected in exactly the same physical direction. There is no trick here with reverse polarity. Here I built two small reference circuits, three separate LEDs, one red, one green and one blue. In the first circuit, all anodes are connected together. This configuration behaves exactly like common anode RGB LED. We have three channel legs and one leg for the anode, because all are connected together. In the second circuit, all cathodes are connected together. This configuration behaves exactly like common cathode RGB LED. We have three color channels and one leg for the cathode, because all are connected inside the RGB LED. Electrically, these two circuits are equivalent to an RGB LED inside one package. The only difference is which side is shared, positive in the first case and ground in the second case. This also clearly shows that an RGB LED is nothing more than three standard LEDs with one common connection. It is also worth mentioning that many SMD RGB LEDs come with 6 pins instead of 4. Like this one I have here. In this version, each internal LED has its own separate anode and cathode. Nothing is shared internally. This is extremely useful because with just one physical RGB LED, you can externally configure it as a common cathode device or a common anode device, simply by how you wire it on the PCB. You are no longer limited by the internal wiring of the package. You decide how the RGB LED behaves. Exactly, this is the most flexible RGB LED variant you can see. And now you can see here our cathode are connected together and they go to the pin here. Now that we understand how an RGB LED is built and wired, we can finally move to the practical part. I will now remove the standard single color LED from our circuit and replace it with an RGB LED. Electrically, this is not a simple one-to-one replacement, because we are no longer dealing with one diode, but with three independent ones sharing a common connection. So we must adapt the circuit properly before powering it up. And we will use common cathode RGB LED. First, we have to replace our power supply because RGB LED needs a little more power. So we will replace our two AA batteries. With 3 AA batteries. We will have 4.5 volts. We'll connect it here and here. Okay, let's see if this works. Yes, it's working. Okay. Now we will move our potentiometer up here because we will need more space in here. So take out this wire like this. This wire we will take out and connect this here. Okay, this resistor we won't need because we will add resistors to every separate channel. Now let's take out our LED and we can place our RGB LED. In this project I will use an SMD RGB LED because in my experience it makes colors much better than typical through-hole versions. You can buy this SMD RGB LED already mounted on small breakout boards with gold pin headers, so they are easy to use on breadboard. I swapped the pin headers on this breadboard so that the LED is now facing upward instead of sideways, which makes it much easier to observe the color mixing. If you use a through-hole RGB LED, everything will work exactly the same way, as long as your LED is a common cathode type. Now let's connect our LED to breadboard. I will connect this somewhere here. Okay, like this. Now we have to connect our LED to diode here and to the transistor here. So I will place here a jumper wire like this. Okay. Every color channel of this LED needs resistor. So for the start I will use 220 ohms and I will connect right side and the left side with resistors like this. This and like this. Okay, now we have 3 channel resistors. For now we will just connect these 3 channels directly to the potentiometer. So I will take jumper wire from the middle pin to this one, like this, and now we have to connect this 2 with this one. So I will take short one, I will connect this 2 lines like this and this. Okay, so now we have connected all channels to the potentiometer. So now we can check if our circuit works. Turn on, LED lights up. It is pulsing, but it doesn't look quite right. It happens because we've changed power supply and our RGB LED needs more power, and we have to adjust our 555 timer section to make it look better. Now let's see if we stop. It works, and if we switch the mode, it is blinking. So everything works, but pulsing doesn't look quite right in my opinion. The LED isn't fading out fully, so we have to fix this. The simplest fix to pulsing LED is by replacing this capacitor. Now we have 220 microfarads. We will replace it with 100 microfarads, and we will see what will happen. Turn on. Now you can see fading in and out looks a lot better. Now let's see if our potentiometer is working. Yes, it works. So everything is fine. Now we have RGB LED in our circuit. So now you know how RGB LED works, what is inside it, and how to mix colors. In the next video I will introduce an NTC temperature sensor, and I will show how you can use temperature to control circuit.